So now let's talk a little bit more about z-scores. We kind of introduced this in the last section. We actually used the idea of a z-score for one of the problems. So to find the z-score, there's a formula that goes with it. It's always the x value minus the mean divided by the standard deviation. So if we have sample statistics, we would use that notation. If we have population, we would use that. So you may see either of these formulas written associated with the standard deviation. It just depends on if you have a population or a sample as to which notation you're using. But it's the same thing. It's always x minus the mean divided by the standard deviation. If you type all of this in your calculator at once, be very careful. Make sure you're using a scientific. Make sure you put parentheses around the top, because you got to compute the top before you divide by the bottom. So what does a z-score do? It tells you the number of standard deviations that a value is above or below the mean. If it's a positive z-score, then the value is going to be above the mean. If it's a negative z-score, then it's going to be below the mean. If the z-score is 0, then that means that value is the same value as the mean. And what this does is it standardizes the value, kind of puts everything on a standard platform, so we can talk more about like normal distributions and stuff like that, which we'll get into later into the course. So let's look at an example. The human body temperatures have a mean of 98.2 degrees Fahrenheit and a standard deviation of 0.62. We want to convert each one of these to a z-score. So it's always the x value, that's what they're giving us, minus the mean divided by the standard deviation. Z-scores are rounded to 2 decimal places. Typically, I got 4.52. So what this is saying is that it's approximately 4.5 standard deviations above that mean of 98.2. Okay, let's do the next one. We have 96.9. So the z-score is going to be 96.9 minus the mean of 98.2 divided by 0.62. Remember, when you type this in the calculator, use parentheses around the top. So I ended up with a negative 2.10, rounded to 2 decimal places. So notice this is a negative value. That means we started with something that was less than the mean. The mean was 98.2. 96.9 is smaller than that 98.2 mean. So that's what the negative means. And we ended up with a negative 2.10. Then that means that if this is our mean, then we are actually about 2 standard deviations less than the mean. And then that third one, 96.98 minus the mean of 98.2 divided by the 0.62. And had negative 1.97. So approximately 2 standard deviations below the mean. Notice we started with something that was smaller than the mean, which is why it's negative. So another measure of relative standing would be quartiles. So quartiles will separate a data set into 4 different values. So if this is our data set, it splits it into 4 parts. So that part that's in the middle, that's actually your median. And we can call that quartile 2. Quartile 1 separates the top 25%, the bottom 25% of data from the middle 25% of data. And we call that Q1. And then if we split that top tier, then we call that Q3. That separates that top 25% from this 25% of data. So the notation we see associated with that would be Q1, Q2, which is your median, and then Q3. So, and the quartiles really are just the median of the lower half of the data and the upper half of the data. And one thing we use this for is a box and whisker plot. So suppose we want to create a box and whisker plot. We take our data set and we find something called the 5-number summary. The 5-number summary consists of the smallest value, the biggest value, and then all 3 of the quartiles. So let's look at an example. Let's say we have this data set and we want to construct a box plot here. So I'm actually going to do this by hand first so you can see what's going on, and then we'll do it in StatCrunch. So there's our data set. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values. So if we separate the bottom from the top, we have 5 values in each set. This is where your quartile 2 will be. That's your median. And your median is going to be, in this case, we don't have a middle value. We have 2 middle values. So we just find the average of those. What would be between 51 and 53? Well, if we find the average, 51 plus 53, and then divide it by 2, we're going to get 52. So that median is 52. So there's your Q2. Quartile 1 is the median of the lower half of the data. So here's your lower half. What number's in the middle? Well, notice everything's already in numeric order, and that's how we found the median to begin with. So there's your quartile 1. There's your median, which is 39. Quartile 3 is the median of the upper half of data, which is this guy, 63. Minimum value is 34. Maximum value is 108. That's the biggest value we have. So there's our 5-number summary. Now the quartiles actually make up the box when we create a box and whisker plot. So if we were to draw a number line, I'm going to start this at 30, and I'm going to go up by 10. So 40, 50, 60, 70, 80, 90, 100, 110. We have quartile 1 at 39. We have quartile 2 at 52. That's your median. And then we have quartile 3 at 63. There's your box. The minimum value is at 34. And then the maximum value is at 108, which is way out here. So that's your standard box and whisker plot. Quartiles make up the box, and then you just draw lines out from the box to your minimum and maximum values. Now, I want to show you how to do that in StatCrunch. So we're going to go to StatCrunch, and we're going to type those values in. So I'm going to go to Stats. Actually, I'm going to go over to Graph. And then Box Plot. Everything's in bar 1. That's the column with my data. And I am going to unclick this option, use fences to identify outliers. We're just going to do the standard box plot first. Click Compute. So there's our box plot. Now this one does, StatCrunch does this vertically instead of horizontally. I drew it horizontally here. That's typically how we see it. But if we hover over, you can see the minimum values, quartile 1, median, quartile 3, and maximum values. And then it gives you this thing called the IQR. The IQR is actually how big that box is. And you can find it by taking quartile 3 and subtracting quartile 1. So it's how long the box is. So if we take that 63 minus 39, that's where the IQR is coming from. Now, the standard box plot is nice, but it doesn't show you any kind of outliers. We can find outliers by using that fence feature. And the way the fences work is it takes 1.5 times the IQR and it subtracts it from the lower end and adds it to the upper end. Okay, so that's where your formulas are going to come from there. And it's going to create kind of like fences around this. So any data values that are within the fence, we consider normal, not outliers. Anything that's outside the fence will actually be an outlier. So let me show you that. In this example, I believe we will have an outlier. So I'm going to Graph, Box Plot. This is called a modified box plot. Now I'm going to use those fences to identify outliers, and I'm going to compute. So you see how the box plot is a little bit different here? If I hover over, it tells us how many values and how many outliers we have. So now the upper limit is a little bit different. It's at 73. 73 is the smallest, the largest value that's inside of those fences. And then notice that this guy, that 108, is outside of the fence. It's an outlier. So there's your modified box plot.